In this video, we're going to learn what a logarithm is and how it's related to exponential forms. So hopefully by the end of this, you will understand both of those forms, how to convert from one to the other. Understand that logarithms are exponents and also change between forms to even solve equations. So let's dig in here. If it is often needed to express exponents in a different way to be able to solve the equation. So this is where logarithms come into play. So let me give you an example. If you were asked to solve the equation 3 to the x power equals 7, of course 3 squared is 9, 3 to the first is 3, so what are you going to do here? This is where a logarithm comes into play. So if you have a statement in exponential form, then you can write it as a logarithm, and it starts by just writing the word log. So you write L-O-G, log, that's short for logarithm, L-O-G. Then I have a couple ways to remember where the numbers go, because you're just going to rearrange the three numbers. So you've got, the 3, the x, and the 7 up here, or down here you've got the y, the b, and the x. So you've got three things, and we're just going to rearrange them. So one of the ways that we start this is not only write the word log, but then we think the base is the base. So the base here is b, okay? The base is the base. So we put that down here as a real small number, by the way. We write it pretty small. That's the base. So this is log base b is what we say now. And now I have another way to remember where the other two things go, because we've got two things that we still need to put places. We need to put the y somewhere, and we need to put the x somewhere. Okay, where do they go? Well, answers to logs are exponents. So let's write that down. Answers to logs are exponents. Answers to logs are exponents. I can't say that enough. It helps me remember where I put the different numbers, because look, in this exponential form, we have an exponent, don't we? We have an x. Answers to logs are exponents, so let's go back to our expression here. What was the exponent, or what is the exponent? It is an x. So we're going to put an x on the right side over here. Okay, answers to logs are exponents, so the exponent over here becomes the answer to the log. Now that only leaves us one more thing to put in there, and that is the letter y. And the letter y goes nice and big right here inside the logarithm, so it's inside the logarithm. So let's use that same technique for my example that I wrote on the top. All right, if I'm going to convert this to log form, this is exponential form to begin with. If I'm going to convert it to log form, first thing I do is I write log. Then I think, okay, the base is the base, so the base is 3. And then answers to logs are exponents, so I put an x here. And then whatever the remaining number is, which happens to be a 7, goes inside the logarithm. Okay, so log base 3 of 7 is x, and that's the answer, log base 3 of 7. Now you might not understand what that is yet. I'll show you how to use a calculator to figure out that value here in a moment. So let's go down here to a few examples where we're going to rewrite in log form. So we've been given exponential form, and we're going to rewrite it in log form. Okay, so the first thing you do is write log. Now, the base is the base. So what is the base in this question? The base is this guy right here, the number 2. So I'll put the little 2 right here. Little 2, that's log base 2. Okay, now answers to logs are exponents. So I'm going to leave a little gap, and I'm going to put the equal sign, and I'm going to put my exponent over here. And the exponent is right here. It's a 2. So I put a big fat 2 there. Answers to logs are exponents, so that must mean the 4 goes inside the logarithm. So log base 2 of 4 is 2. That's a true statement. Okay, let's come over here. Again, we're just trying to understand how to write a log, and then in a bit I'll show you how to use a calculator to do that as well. So here we have a negative exponent, but that's okay. We understand negative exponents simply mean fractions. So we're looking at this exponential statement, which is true. 3 to the negative 4th is 1 over 81. So in log form, we write log. The base is the base. What is the base in this question? The base is 3. So we have log base 3. Answers to logs are exponents, so I'm going to put the negative 4 over here. And then inside the logarithm goes what's remaining, which is the 1 over 81. So answers to logs are exponents. That was the -4. So log base 3 of 1 over 81 is -4. That's a true statement. Okay, let's keep going. Here we have an exponential equation. Oh, maybe we could solve it using rewriting it in exponential form. Let's see. I'm sorry, rewriting in log form. So we write log. 4 to the what power is 16? Well, it's 2, but I'll show you in a moment here. So the base is the base, right? Log base 4, and then answers to logs are exponent, and we get log base 4 of 16 is the solution, x. Okay? And since answers to logs are exponents, we could ask ourselves 4 to the what power is 16? The answer is 2. So 2 is the solution here. That's the same thing as log base 4 of 16. All right, this one, again, we would need to use, this is like that first problem that I put at the very top of these notes with base 3. This is base 2 though this time, so we're going to do log base 2. Answers to logs are exponents, so the x goes over here, and then that must mean the remaining 7 goes inside the logarithm. All right, so here in a moment, I'm going to show you how to type that in the calculator. So maybe we can come back to this problem and actually get the answer by typing it into a calculator. Let's go backwards now. We're being given log form. We're being given log form, and we're being asked to write exponential. So the base is the base. So remember, we're going to write something to the something power equals something. So answers to logs are exponents, and we want to keep the base the base. So what is the base in this log statement? Log base 7. So that goes in here. Now answers to logs are exponents. Here's the answer to the log, so that goes up here as an exponent. So 7 to the 3rd power equals, that must mean the 343 goes in here. So you might put that in the calculator. Does 7 to the 3rd power equals 343? Yes, it sure does. Okay, so you just rewrote it in exponential form. All right, let's take a look at this guy. Log base 5 of 1 over 625 equals -4. So the base is the base. The base is 5 on that logarithm statement, so we'll write it down below as a nice big 5. Now answers to logs are exponents, and the exponent is going to be negative this time. That's okay. We understand what negative exponents are. It simply means we have a fraction on our hands. So I just rewrote the log statement in exponential form. We got one more over here. We would write 4 to the 7 power equals y. So then if you want to put that in the calculator, you could figure out what y might be. All right, so there is a way to type these in the calculator, logarithms. Here's how it works. log, log of base a of b is the same thing. By the way, most calculators can't do like log base 2, log base 3, log base 4. They can do two things. They can do log base 10, which is the plain old log, and then they can also do a thing called the natural log. So it's convenient to be able to change the base to something that our calculator can do. So here's how this goes. We write log, log of b, divided by log of a. Notice that the base goes down low because the base is always sort of foundational, right? The base is under everything is the way I remember that. So the base goes on the bottom. Now some calculators will put parentheses here. So I just wanted you to realize you do need to close this parenthesis whenever you type it in your calculator or you type it into Desmos. You'll need to be careful how you type that in. So let's use the change of base formula with these examples down below. So if we change the base, we would see this would be log 8 divided by log 2. And you can type that in your calculator and it will say 3. Log 8 divided by log 2 is 3. Let's come over here. Log base 7 of 24. Now, again, your calculator might not be able to do log base 7. Now, if you have a TI-89 or higher, or like the Inspire, you can put these in directly, and I'm happy to show you how to do that. I think it's under the math settings, math button, and I bet you can find it. But this would be log of 24 divided by log of 7. And you would type that in your calculator and get your decimal. So let me do that right now. All right, I just typed it in my computer and I got 1.633. So you might want to give that a try. Try it in your own calculator. Make sure you get 1.633. All right, over here, why don't you pause the video and see if you can figure out what decimal this would be. All right, so we want to rewrite it as using that change of base formula. So this is the log of the square root of 18, which is a number, all right? So we'll just type that in the calculator here in a moment. All divided by log base 3. So you want to type that in the calculator, and what do you get? I'm going to do it right now. Okay, I just typed it into my computer. I actually used Desmos this time, and I got 1.315. 1.315. So hopefully you got the same thing. So you just found log base 3 of radical 18, but you did it using the change of base formula because maybe your calculator can't do log base 3. All right, so going back up top here, remember I said I would spiral back here. Our answer to this equation, 3 to the what power, is 7. Well, now we can figure out the answer. And we use the change of base formula to type this in the calculator. This would be log 7 divided by log 3, because remember the base always goes down low. So let me type that in. All right, I got 1.771 when I type that in. So 1.771 would be the exponent right here. So 3 to the 1.771 would be the exponent that solves that equation. All right, so on this next page, hopefully this will go quickly here for you now that we've sort of set the stage on what a logarithm is and how to solve it. 16 to the what power is 64. So I might not know, right? 16 to the what power? 16 squared is 256, and that's way too high. 16 to the first is 16, so it must be between 1 and 2. Let's figure it out by writing it in log form. So we're going to write log. The base is the base. Answers to logs are exponents, and then that means the 64 goes right there. Okay, so now I can go to my calculator, and I can type in log 64 divided by log 16 using that change of base formula, and let's see what the answer is here. Okay, I got the answer, and it is 1.5. So 1.5 would be the exponent that solves the original equation, and I used a logarithm to solve it. I did have to use that change of base formula at the end. Okay, so let's solve this equation. This is really similar to that first one that I did today. So this would be log base what? Log base 3 of 8 equals x. So we're going to type that in our calculator as log 8 divided by log 3. Log 8 divided by log 3. Let's see what we get. All right, I got 1.893. So again, make sure that you got that when you type that in. So that would be the exponent that would solve this equation. It happens to be a crazy decimal, and that's okay. Sometimes answers aren't nice and round, right? Okay, oh my goodness, here we've got a little bit of algebra mixed in. So let's first write it as a logarithm and see if that helps. I guess I should say there's no common base here, right? 8 is 2 to the third, and 9 is 3 squared. That's not a common base, so can't even convert to a common base like we did in the last section. So we'll use logarithms. We're going to write log base 8 of 9. Remember, answers to logs are exponents. Notice how I'm writing that nice and big now, x plus 1. So if I subtract 1 on both sides, I'm going to write it out front, so hopefully that doesn't confuse things. We're going to write it like this. Log base 8 of 9 equals x. Okay, so in the calculator, here's what we're going to type in. We're going to type in -1 plus log 9 divided by log 8. And that will be the answer that we get. And it'll probably be a decimal. Let's type it in. Okay, I got 0.0567 when I type that in. Actually 6.6. So let me correct that for rounding purposes. Just make sure you don't get confused. 0.0566. All right, moving on over here. First thing I want to do is to take a look at this question and see that I've got this multiplication here. So before I go to the logarithm world, I think I want to get rid of that 3. So what I'll do is I just divide it off of there, get it to the other side. 2 to the x minus 2 is now equal to 8/3. Don't write that as a decimal. Just leave it 8/3 for now. Now we'll convert to log form. Log base 2 of 8/3 is, remember, answers to logs are exponents. You can then add 2 to both sides. And again, I like to write it out front like this so that we get 2 plus log of, I'll just go ahead and do the change of base formula. That's 8/3 divided by log 2. Okay, so that's what you need to type in your calculator, 2 plus those 2 logs divided. So let me do that and see what I get. Okay, so x equals 3.415. 3.415. Remember, I had to divide by 3 first. That was the new thing in that question. So it's always good to ask yourself, hey, why is this on here? What's new? The new thing was I needed to divide by 3 first before solving that, in order to solve that. All right, we've got a couple more questions here. So if I write this in exponential form now, see how this is called a log equation. How crazy is that? You're like solving log equations already. So 8 to the third, right? Answers to logs are exponents. So this exponent I put up here on the base. All of that equals n plus 1. So if I subtract 1 on both sides, I don't get 7 to the thirds. Please don't write 7 to the thirds. It's 8 to the third power. Subtract 1 equals n. So you need to type it in the calculator exactly that way, and here's what you get. Okay, you get 511. N equals 511 is the answer here. 511. All right, we got another question here, and then the last are really easy. Just sort of a review. So this question's pretty easy. Solving for x. We're not solving for the base, we're solving for what's inside the logarithm. So we write it as an exponential. The base is the base. So 2 to the 7th power. Answers to logs are exponents equals x. There's your answer, 2 to the 7th power. Now if you type that in the calculator, it's a pretty big number. It is, let me do that now. The answer is 128. So either one would be acceptable for me. All right, one last thing. This is just a reminder. This may help. Answers to logs are exponents. So we can do these without a calculator, folks. Log base 3 of 9. Log base 3 of 9. So you ask yourself, 3 to the what power is 9? The answer is 2. You see that? 3 squared is 9. Log base 2 of 8 is what? It is 3, since 2 to the third is 8. Log base 5 of 25 without a calculator is what? It is 2, because answers to logs are exponents. All right, so let's go back to the beginning of the notes and just go through our I can statements here. Hopefully now you sort of understand, hopefully actually really well, that you understand exponential and log forms, how to convert between the two. You understand that logs are exponents, and then you also learned how to use the change of base formula and change between the different forms. The change of base formula allowed us to actually figure out, like in this example, we figured out the decimal in the end. Not only did we write it as a log, the answer, but we actually figured out the decimal using that change of base formula. All right, hopefully this was helpful, and good luck on your assignment. Okay, until next time.